Okay, so we all know what happens when you mix baking soda and vinegar. You get a volcano, an eruption, lots of fizz. And in the same way, scientists can use certain reactions to make the ground below our feet do the opposite of fizz, collapse. This is why at one point they considered destroying the Grand Canyon to make a giant wine cellar. Let me explain. In this episode of Peril Below, we are excavating one of the largest construction projects ever undertaken, a massive subterranean marvel located deep beneath the arid plains of Western America. What I am describing is the Hoover Dam, one of the most impressive feats of engineering in human history. But did you know there is a terrifying peril lurking just below its towering structure? The ground beneath the dam is actually slowly but surely sinking into a massive caldera, a gigantic volcanic crater that stretches for miles. This poses a serious risk to the stability of the entire structure and, if left unchecked, could eventually lead to the catastrophic collapse of the Hoover Dam. Now, before we move further, let's have a quick chat about calderas. You see, just like the small crater you get when you drop a bowling ball on an anthill, calderas form due to a sudden void created by the removal of large amounts of material, except that instead of an anthill, it's usually a bunch of rock, and instead of a bowling ball, it's usually a bunch of magma. So, the stuff that makes up our planet's crust is made up of huge, irregularly shaped blocks known as tectonic plates. These plates are in constant motion, albeit extremely slow motion. And when these plates collide, the process can cause the Earth's surface to buckle and fold, creating mountain ranges, and yes, also massive voids filled with molten rock called magma chambers. Now, as the magma chamber empties during an eruption, the overlying rock can collapse, forming a caldera. And while this might sound like a rare occurrence, they are actually surprisingly common across the globe. For instance, there is the famous Yellowstone caldera, home to North America's largest active supervolcano, which has had 3 major eruptions in the past 640,000 years, creating a massive caldera over 45 miles wide. Another example is the Valley of 10,000 Smokes, near the Katmai National Park in Alaska, formed after the Nova Rupta volcano erupted in 1912, covering an area of over 600 square miles. Then we have the famous Lake Toba in Indonesia, which was formed by a super-eruption around 74,000 years ago, leaving behind a caldera nearly 800 miles wide. However, out of all these calderas, one stands out in particular because of its location right beneath one of the largest dams in the world, the Hoover Dam. The Hoover Dam, named after the 31st U.S. President Herbert Hoover, is a concrete arch-gravity dam that stands at an impressive 726 feet tall and spans across the Colorado River in the southwest region of the United States. The construction of the dam began in 1931 during the Great Depression and took 5 years to complete, being finally completed in 1936. At the time of its construction, it was the tallest dam in the world, and it remains the highest in the United States. The purpose of the Hoover Dam was to create a reliable water source for the growing population of the western states, which led to the creation of Lake Mead, a reservoir that stores water for both industrial and domestic uses. Additionally, the dam provides hydroelectric power to 7 states in the western part of the country. However, as impressive as this feat of engineering is, it was built in a seismically active area, and researchers believe that it was constructed in a place that sits atop a previously unrecognized magma chamber. How did they figure this out? Well, the answer lies in the very core of the Earth. Scientists were able to identify this potential peril by conducting seismic studies on the area. They did this by sending vibrations into the Earth and measuring how long it took for them to come back. By analyzing the data, they discovered a low-velocity zone beneath the Hoover Dam, suggesting the presence of a magma chamber filled with molten rock. This revelation came as quite a surprise, since the United States Geological Survey had previously conducted studies in the 1970s that failed to detect any signs of volcanic activity in the area. However, new research suggests that there is indeed a magma chamber located only 12 miles beneath the Hoover Dam and extending down over 12 miles into the Earth's crust. That's like having a ticking time bomb underneath one of the greatest engineering marvels of the modern world. And things get even more complicated when you consider that Nevada is situated on top of multiple active fault lines. But you're probably wondering, does this mean we're all doomed? Will the Hoover Dam collapse and take down Lake Mead with it? Well, not so fast. Despite this potentially catastrophic discovery, experts remain cautiously optimistic. According to the chief of the U.S. Bureau of Reclamation's Upper Colorado region, the presence of magma does not pose a significant risk to the structural integrity of the dam. This is because the Hoover Dam was designed to withstand seismic activities, such as earthquakes. In fact, it was constructed to withstand an earthquake twice as powerful as the one that struck San Francisco in 1906. Additionally, the dam has undergone rigorous testing and inspections since its construction, ensuring its continued safety and reliability. However, it is important to note that the situation is still being closely monitored by experts. Regular seismic surveys are conducted to ensure that there are no changes in the underground activity. One of the main reasons for their optimism is that the magma chamber is located deep beneath the surface. Magma chambers closer to the surface would obviously be much more problematic. But since this one is so deep, it poses less of a direct threat to the dam itself. Moreover, the magma is believed to be relatively old and inactive, meaning that there is no immediate danger of an eruption. Nevertheless, scientists are still concerned about the potential risks associated with the magma chamber. For instance, the movement of magma beneath the surface can cause subtle changes in the land, leading to increased earthquake activity in the area. While the Hoover Dam was built to withstand earthquakes, a significant increase in seismic activity could still pose a threat to the dam's structural integrity. Additionally, the long-term stability of the surrounding rock is also a concern. The presence of magma beneath the surface can cause the surrounding rock to become weaker and more susceptible to erosion over time. This means that even without an earthquake or volcanic eruption, the Hoover Dam may eventually face challenges due to the changing conditions in the ground beneath it. So while experts may be saying that there is no immediate danger, it is clear that the presence of a magma chamber beneath the Hoover Dam is a serious issue that needs to be closely monitored. It's a stark reminder that even the most impressive feats of human engineering are ultimately at the mercy of the forces of nature. So here's what they've done. Experts have been continuously monitoring the situation to mitigate any potential risks. Regular inspections and maintenance are carried out on the dam to ensure its safety, and any signs of unusual activity are quickly addressed. Additionally, advanced technologies such as remote sensing and real-time data analysis are being used to closely monitor the movement of the magma chamber and any changes in the surrounding rock. They've also been working on developing contingency plans in case of an emergency. These plans include procedures for evacuating the surrounding areas and providing timely alerts to the public in the event of a volcanic eruption or other major incident. Furthermore, researchers are also studying the history of volcanic activity in the area to better understand the behavior of the magma chamber and predict any potential future activity. By learning from past eruptions, they can develop more effective strategies for managing the risks associated with this underground peril. Despite the challenges, experts remain committed to ensuring the safety of the Hoover Dam and the surrounding communities. They understand the critical role that the dam plays in providing water and power to millions of people in the western United States and are dedicated to preserving its functionality for generations to come. As technology continues to advance, experts are also exploring innovative solutions for managing the risk posed by the magma chamber. This includes the use of advanced materials and construction techniques to reinforce the dam and enhance its resistance to seismic activity. Additionally, they are also investigating the possibility of using artificial intelligence and machine learning algorithms to analyze real-time data and provide early warning signs of potential problems. While the future remains uncertain, one thing is clear: the presence of a magma chamber beneath the Hoover Dam is a challenge that will require ongoing monitoring, research, and innovation to overcome. It serves as a reminder of the incredible power of nature and the importance of investing in the safety and resilience of our infrastructure. So, in a way, the peril below the Hoover Dam is a testament to the ingenuity and determination of those who built it and those who continue to work tirelessly to ensure its longevity. It is a story of courage and resilience in the face of nature's fury, and a reminder that even in the face of adversity, we can find solutions and build a better future. And now it's time to hear from you. What do you think is the craziest peril you've ever heard of? Share your thoughts in the comments section below. Also, don't forget to give this video a thumbs up and subscribe for more exciting content. Thanks for watching, and I'll catch you in the next one.